Well, now that we have complex numbers, we can use those numbers as solutions to equations that we solve, and oftentimes they show up in solutions to quadratic equations. So I want to come back to solving quadratic equations, and we're going to do an example in just a moment utilizing the quadratic formula. So I want to talk about the quadratic formula and a part of the quadratic formula that we call the discriminant. Where we're going to look at is right here, the part that is underneath the square root in quadratic formula. The discriminant is just that part. The discriminant is just simply the b squared minus 4ac. And the value of the discriminant can tell us something about the types of solutions and the numbers of solutions that our quadratic equation can have. So let's talk about that. There are three possibilities. Let's list them out. The b squared minus 4ac can be a positive number, which means it can be bigger than 0. The b squared minus 4ac can be a negative number, which means it can be less than 0. Or the b squared minus 4ac can be equal to 0. That's all inclusive. Those are our three possible cases. It can be bigger than 0, less than 0, or it can be 0. But it can't be anything other than those possibilities. So what does that tell us? Well, if we have a value that is bigger than 0, okay, say for example 9, and so I had the square root of 9, well then I'd be doing negative b plus 3, negative b minus 3, and adding 3 and subtracting 3 would give me two distinct real solutions. Okay. Now what about if the b squared minus 4ac is negative, if it's less than 0? So let's pick a negative number, say it's negative 4. So I'd have the square root of negative 4. The square root of negative 4 is 2i. So I'd be adding 2i, subtracting 2i. I'd have two distinct complex solutions. Now if the b squared minus 4ac happened to be 0, so I had the square root of 0. Well, the square root of 0 itself is just 0. So therefore I would have negative b plus 0 and negative b minus 0. Of course, adding 0 or subtracting 0 does not change the value of negative b, so I would have in this case just one real solution. So the value of the b squared minus 4ac, the value underneath the square root part of the quadratic formula, tells us two pieces of information. It tells us the type of solution, either real or complex, and it tells us how many solutions we can expect to have, either two or one solution. Well, let's look at one final example. On this example it says solve the quadratic equation. Let's begin by finding the discriminant. The directions don't call for it, but let's just say we go ahead and do that so we can talk about what we learned on the previous slide. So if I find the b squared minus 4ac, I would have 3 squared minus 4 times 1 times 3. That's 9 minus 12, which is negative 3. That tells me that I'm going to have two complex solutions. It doesn't actually tell me what the solutions are, okay? So don't misinterpret the negative 3 and think, oh, the answers are negative 3. That's not the case. That's just the value of the discriminant, and this is the implication of that we have two complex solutions. Now let's actually find those solutions. We know now what we can expect. We're going to get solutions that have imaginary numbers in them. So let's kind of see that through now. Quadratic formula, rewrite it, negative b plus minus square root of b squared minus 4ac, all divided by 2a. So we have negative 3 plus minus the square root of, now here the b squared minus 4ac, it's the same b squared minus 4ac that I have over here, and I've already worked out its value to negative 3. So there's no sense in reworking that value. I'm just going to place the value there, negative 3 divided by 2 times 1. So I get x equals negative 3 plus minus, in this square root, the negative part comes out as our imaginary unit. So we get plus minus I square root of 3 divided by 2. And if we split that up into two fractions, we get negative 3 halves plus or minus square root of 3 over 2i. There's our two complex solutions. One of them is the plus, the other one is the minus. They're of course complex because they've got the imaginary part here and they've got the real part there.